Hi, I'm Jared Hyman, an assistant professor of chemistry at Elon University. Today, we will be discussing the proper titration technique using the complete single burette assembly kit available from Carolina Biological Supply Company. This is the first in a two-part video series on titration. The purpose of a titration is to quantitatively determine the concentration of an unknown solution, commonly called the titrand or analyte, by adding a volume of a chemical with a known concentration called the titrant. To mark the endpoint of a titration, an indicator is added to the analyte. Let's review some of the equipment that's needed for a titration. Carolina's complete burette assembly contains the basic equipment to get you started, including a burette, ring stand, and a burette clamp. A burette is a long, narrow, graduated tube used to add titrant. It has a stopcock to regulate the flow of liquid. Notice that the markings on the burette go from lowest at the top to highest at the bottom. The ring stand and burette clamp are used to mount and secure your burette. Other materials you will also need include a small funnel to help you fill the burette, a 125 milliliter Erlenmeyer flask, which works best for titrations. The shape of the flask allows for more vigorous swirling than a beaker or other glassware and minimizes spill hazards. A volumetric pipette and pipette bulb to transfer a known volume of analyte to the flask. A wash bottle filled with deionized water, a beaker or flask of titrant and of analyte, indicator selected for your reaction, a reading card to help read the meniscus, and a sheet of white paper to help visualize the endpoint. To prepare your burette for the titration, it is good laboratory practice to rinse your burette thoroughly with deionized water, then with a small amount of titrant. After each rinse, open the stopcock to allow the liquid to drain out the bottom. If there is a lot of liquid clinging to the walls of the burette, then thoroughly clean your burette and repeat the rinse process. The accuracy of this technique is dependent on the titrant flowing into the flask and not sticking to the walls of the burette. Mount the burette in the clamp, making sure it is positioned vertically, and there is enough room to position your flask underneath the tip. Check to see that the stopcock is in the closed position. Insert the funnel into the top of the burette and fill with titrant almost to the top. Filling exactly to the zero mark is not necessary, but you do need sufficient titrant to complete the reaction. Check the column for air bubbles and gently tap to free them from the side walls. Remove the funnel. Place the Erlenmeyer flask under the tip and open the stopcock to allow a few milliliters of titrant to flow through, releasing any trapped air. Rinse the tip of the burette with water. Empty the liquid into a waste container and thoroughly rinse the flask. It is not necessary to dry the flask. Record your starting volume. It is important to accurately read the volume on the burette. First, note that the liquid forms a concave meniscus because the water pulls itself up the side walls of the glass. You should read the volume from the bottom of the meniscus at eye level. Secondly, it is important to read your volume to the correct number of significant figures. This burette indicates volume to the nearest 0.1 milliliters. With any graduated glassware, record the volume to one additional decimal place beyond the smallest graduation. In this case, record the volume to the nearest hundredth of a milliliter, estimating the final place. Use the volumetric pipette to transfer the analyte to the flask. Add a few drops of indicator to the flask and swirl. Place the flask under the tip of the burette. Record this volume. Placing a piece of white paper under the Erlenmeyer flask may make it easier to detect the color change. Operating the burette requires two hands. One hand turns the stopcock, while the other hand swirls the flask. Practice turning the stopcock a few times to familiarize yourself with how quickly the flow starts and stops. It is common laboratory practice that the first titration is an estimate. Open up the stopcock and allow the titrant to enter the flask quickly. Continuously swirl the flask. As the volume of titrant in the flask increases, the color of the indicator appears, then disappears as you swirl. When the analyte becomes a colored solution, close the stopcock. Record the final volume of the burette. Subtract the initial volume from this final volume to get the estimated volume of titrant needed for this titration. Knowing the volume that is a little past the endpoint, Subtract 5 milliliters from that number to get the amount of titrant that can be safely added before a slower addition is required. As the estimate titration shows, a dark-colored solution indicates an excess of titrant has been added. The desired endpoint is a pale, faintly colored analyte. To reduce the risk of passing the endpoint, slow down the addition of titrant when flashes of color begin to appear in the analyte. Adjust the stopcock to slow the flow of titrant to a dropwise rate. Continue to swirl the flask with one hand and keep the other hand ready to close the stopcock. When you notice the indicator taking longer to fade, close the stopcock. Rinse the tip of the burette with deionized water and swirl the flask. Record the final volume on the burette. If the analyte remains faintly colored, then you have reached the endpoint. If the analyte is still colorless, then repeat these steps. Add a drop, rinse, swirl, and record until a faint color persists. Typically, titrations are performed in triplicate. Use the average volume of the titrant required to reach the endpoint for any calculations. You now know how to properly perform a titration. Be sure to check out the second video in this series. In that video, we will go over the proper procedure for determining the concentration of an unknown acid solution using a base of known concentration. Carolina has everything you need for your chemistry lab. Visit us at carolinachemistry.com to see our complete line of products and kits for chemistry.
We're now going to do a titration. A titration is a process that a chemist uses to determine the concentration of a solution. And the reason we do that is sometimes when you would think that if we weigh out a substance and find out how many moles of that and putting in our volumetric, we would know exactly the concentration. Some compounds are very hygroscopic and they'll absorb moisture from the air. For example, sodium hydroxide is very hygroscopic. When we take a sample out of a closed container, it's a nice solid tablet. But when we put it on the balance and wait a few minutes, it's going to absorb moisture from the air and thereby changing the mass. So our mass is not going to be a true mass. So in cases like that, what we have to do is we have to take a known concentration. In this case, we know the concentration of the hydrochloric acid because we can measure it exactly. And we're going to use that to standardize the solution that I made. Now I think I measured out what I thought was a 1.0 molar solution. So what we're going to do is decide, is that 0.9 or 1.01, and get this to 3 significant figures and get the exact concentration of our sodium hydroxide. To do that, we're going to use a burette. And this is a burette. You can see that it's calibrated. This burette holds 50 milliliters. This stopcock is a Teflon coated stopcock that has a hole through the middle. So if it's parallel with the glass, it's open. If it's perpendicular, it's closed. If I want to do just a small dropwise, I can turn the knob here. Okay? So I'm going to close this, and I'm going to put our sodium hydroxide that we want to standardize in the burette. So I'm going to pour this just a little bit above the 0 mark. But since I'm not sure how clean my burette is, I'm going to rinse that burette with a little bit of the sodium hydroxide just to make sure that if there was any acid in here before, I'll neutralize it and then I'll just waste it. So this way I make sure that my burette is clean and has excess sodium hydroxide, if anything, in here. Okay, so I'm going to close it at this point, and then I'm going to refill it. What you'll notice is that it's closed here so that there's air in this part right here. So when I put it back in our burette stand, I'm going to take my waste beaker and put here and make sure this is filled with solution. And then I'm going to look at the top, and I'm going to use a burette reading card. It's just a card with a piece of tape on it that gives me a reference, so that when I look at this, I can see exactly the volume. And you can see I'm above 0, so now I'm going to let it out a little. So it's on the 0 mark. This is my waste container, so I'll set that aside. In my Erlenmeyer flask, I'm going to use the hydrochloric acid that's standardized. Okay, and to get exactly 25 milliliters, this is very much like our volumetric flask. It's been calibrated to exactly 25 milliliters. This is 4 significant figures, 25.00. So we're going to fill it to that mark right there. What I'm going to do is pull it a little bit more than I need. So I'm getting higher than the mark, and then I'm going to let it out slightly. So I'm right at the meniscus. I'm going to take this out, and then I'm going to take off the bulb and just let gravity work. Now these are factory calibrated. So when you let the solution out of a volumetric pipette, there will be a little drop left on the end. You don't want to worry about that because the calibration includes just the amount that leaves the pipette. Okay, so we'll wipe off that drop. Now we have our 25 milliliters of hydrochloric acid in our Erlenmeyer. Now since we're using 2 clear solutions, we need to have something that will tell us when we have reached the end point. So I'm using phenolphthalein, and in an acid solution, phenolphthalein is clear, but in a basic solution, phenolphthalein is going to turn pink. So what we know is that we know exactly how much hydrochloric acid we have, and we're going to add exactly that same molar concentration, and when it turns pink, we'll know we've gone 1 drop too far. Okay, so I'm going to adjust this so that the drops are going to go definitely into my Erlenmeyer, and they're not going to splash out. I'm setting this whole thing on a stirring hot plate, so I have a magnetic stir bar that's going to help me keep everything stirred. And now we're going to gradually add. You see that pink color that comes right away? And then it disappears. So we can keep adding as long as that pink color is there. And since I know that we have a 1 molar solution and we had 25 milliliters, I know it's going to take about 25 milliliters of my sodium hydroxide. Can you see that pink color? But it goes away very quickly. When it begins to stay, then we're going to slow down the rate at which we're dropping. You see, we're almost there, so I'm going to just try to do drop-wise. If I think I'm almost there and I want to just add a half a drop, I can take water and just rinse off that end, and that last drop will fall on this. I think we have reached our end point. So at this point, what we know is we have equal moles of the sodium hydroxide and the hydrochloric acid. So we want to read our volume. Our volume is 21.5 milliliters. Okay? So now you do the calculations.
In this video, you will learn how to perform an acid-base titration. We will be using titration to determine the concentration of an unknown base using an acid of known concentration. For this titration, we will be using 0.1 molar hydrochloric acid to determine the unknown concentration of a sodium hydroxide solution. The progression of the reaction will be determined using phenolphthalein, a pH indicator that is colorless in an acidic environment and pink in a basic environment. First, set up the titration apparatus. Clamp the burette into a stand so that it is vertical with the stopcock at the bottom. Make certain the stopcock is in the closed position. It is closed when it is turned perpendicular to the burette. Using a funnel or pipette, fill the burette with the base of unknown concentration. In this case, we are using a sodium hydroxide solution. The final amounts can be added drop by drop using a pipette. Read and record the volume of sodium hydroxide in the burette by reading the bottom of the meniscus. Next, measure 10 milliliters of 0.1 molar hydrochloric acid using a graduated cylinder. Pour the 10 milliliters of hydrochloric acid into a flask. Add 2 drops of phenolphthalein to the hydrochloric acid solution. Gently swirl the solution to mix. Place the flask directly under the burette. Then place a white background, such as a piece of paper, under the flask to help detect color changes in the solution. Slowly add the sodium hydroxide solution to the flask by turning the stopcock parallel to the burette. The hydrochloric acid solution should initially turn pink, which then disappears upon stirring or swirling. Continue to add the sodium hydroxide solution until the pink color takes longer to fade. Then add the sodium hydroxide solution in single drops, making sure that each drop is thoroughly mixed before adding the next. Continue to add sodium hydroxide 1 drop at a time until the hydrochloric acid solution stays pink, indicating that the acid has been neutralized. Read the volume of the sodium hydroxide on the burette and record this amount in your lab notebook. The entire titration should be repeated 2 more times, and then calculate the mean or average volume of the sodium hydroxide solution required to neutralize the hydrochloric acid.